Okay. My name is Miguel Lavalle, and I'm the Neutron PTL. I've been the Neutron PTL for the past cycle for Queens, and I'm still working as a PTL for the Rocky cycle. And this is the Neutron project update, and we are going to cover both what we did in Queens and what we plan to do in Rocky, and a few things that we are planning to do in subsequent cycles. I see some familiar faces, but I see a lot of not so familiar faces, so I'm glad that you chose to come to the Neutron presentation. So just to put everybody on the same page, so this is the mission statement for the Openstack networking project. We don't call it officially Neutron; it's the Openstack networking project. And essentially, the idea is that we are going to provide networking abstractions to the rest of the Openstack projects. And the idea is that those abstractions have to be technology agnostic. They have to be scalable, and of course, since this is happening in a cloud environment, it has to be on demand. So that's pretty much what defines the mission of the OpenStack networking project. And as we will see during the presentation, this OpenStack networking project is more than just Neutron. So in the beginning, there was no Neutron when OpenStack started to be developed. All the networking abstractions were baked in Nova, and then the community decided that we needed to go beyond the rigid networking that Nova networking allowed. We wanted to give users control over arbitrary networking topologies, and we wanted not only that, we wanted each tenant to be able to define its own networking topology, and that's really the genesis of the OpenStack networking project. It was founded during the Diablo cycle. For several cycles, it was an experimental project, and then we were adopted as the official networking provider for OpenStack. And as of the last cycle, essentially 86% of all OpenStack production deployments use Neutron as their networking component. I assume that the other 14%, they still use Nova networking. For some reason. And we have 240 contributors that committed code to the Neutron group of projects. That's based on Stackalytics that we use to see who's contributing, how many lines of code, how many patches. And there were 200 people, distinct different people that made a commitment during the Queen cycle. And out of those, about 107 contributed directly to the Neutron core component. This is just a little overview of what's the architecture of Neutron. Neutron, since the beginning, was conceived was designed as in principle, an API with 3 basic abstractions: networks, ports, and subnets. And we've been extending those 3 basic resources over the different cycles. We've been adding what we call extensions. Every time you add a new resource to the API, we create a new extension. Or every time you add new attributes to an existing resource, we need to make that discoverable through an API extension. This is a little different to other OpenStack projects. So other OpenStack projects use micro versions. We don't. We use extensions. And if you want to if you are running against Neutron deployment and you need to know what that Neutron deployment is capable of doing, you need to list the extensions, and that's how you discover what the requests that you can do against that Neutron API. Neutron is pluggable, meaning that the way these API abstractions, API resources are implemented can change the way you implement those resources based on the plugin, the plugins that you use. And as we are going to see, we have several different plugins that can implement the Neutron API. And then you can have many different backends in the compute nodes that implement those abstractions using different technologies. So that's probably about it. So originally, many cycles ago, we were a single project. We had everything, all the abstractions under a single GitHub repo. And then over the time, we realized that especially the core team was becoming a bottleneck to developing and letting the different services and the different resources evolve on a timely manner. So over the time, we have been moving the code we have been disaggregating the code from Neutron, from a single GitHub repo. We have been disaggregating that into different repos. And that's what we call the Neutron Stadium. It's a family of interrelated projects that provide all the different services that Openstack networking has to provide. And that means that some of them are complementary and some of them replace other components of the family. The idea is that the Neutron core team still is responsible for providing architectural guidance, API design guidance, but each one of those stadium projects, those interrelated projects, has its own development team, and they evolve and they have their development activities dictated under their own speed, under their own calendar and priorities. So the Neutron core team provides architectural guidance, API reviews, release management, and all that. And in exchange, the sub-projects, the projects that belong to the family, they pledge to follow a set of guidances in terms of documentation, in terms of testing, in terms of stable branches. And more important than anything else is that each one of those interrelated projects are open source from the beginning, from the ground up. This is what currently constitutes the Neutron Stadium. As you can see, we have different backends. You can take the Neutron reference implementation, which is based on agents. You can take that out and use some of those backends. We have different APIs that extend the resources that are offered by Openstack networking. And then we have a set of libraries, Neutron Lib, the Tempest plugin, and OBS-DB app. We have a client. We have a set of dashboards. And we have the specifications repo. Every time the community wants to extend the functionality of Openstack networking, we go through the process of developing a spec, reviewing that spec, and all those specs lives in the Neutron specs repo. So as far as what we deliver in the Queen cycle, I wanted not only to cover what we did in Neutron Core, but I wanted to cover as much as possible the different members of OpenStack networking stadium family. So essentially from the Neutron core, I want to emphasize or highlight 3 things that we did during Queens. We added QoS, bandwidth limit rules, to floating IPs. Today, it's possible to assign a QoS policy to a floating IP, and you can limit the bandwidth that floating IP is using. We added login to events in security groups, so now you can have all the events that take place in security groups, and we capture that in the database, and you can audit that and see what happened with your security. We are improving the API as far as filtering, but not only. We started in Queens adding better filtering, and that's something that we are continuing evolving in the Rocky cycle. The overall goal here is to make we have discovered that the API is not necessarily consistent in the way it responds to different ways of querying and filtering, and really the emphasis of this effort is to make the API more consistent in its behavior. We used to have, many cycles ago, a VPN as a service, and then we found that component wasn't being developed and supported in the way that the community expected, so it was removed from the family of projects. There was a dedicated group of developers that took the challenge to bring it up to speed again. And we were very happy to be able to admit VPN as a service back into the family in the last cycle. And we integrated that component better with the Neutron L3 agent. It's not a separate binary anymore. So we made great progress. With Firewall as a service, we made a lot of progress with the implementation of the version 2 API. That's been a continuous effort for several cycles. It continues in Rocky, and we added more features there. The suite of Neutron Tempest tests used to live in the Neutron tree up until the last cycle. And now that's been disaggregated into its own repo. And what that allows us to do is that all the projects in the family can now use those same Tempest tests and do their testing. Networking OVN added a binding for SRIOV ports. They implemented DVR, distributed virtual router, which was a functionality in the Neutron core. Now it's part of OVN, and automatic L3 high availability support. We have the ODL sub-project, the Open Daylight. They also implemented support for SRIOV, migrated to Zulv 3, and they are supporting now the nitrogen release of Open Daylight. As far as networking BGP VPN, we implemented the support for L2 and L3 types of VPN, and they are supported now by the Neutron ML2 reference driver, both OBS and Linux Bridge. They added better control for the routing, and new VNI optional attribute for VXLANs. There's another project, Networking Backpipe, which is related to BGP VPN, and it's been evolving to support the functionality of BGP VPN, and they also introduced a driver for networking SFC. In the case of networking SFC, they implemented a more complex way to support service function chains. And finally, with dynamic routing, we are now supporting 4 bytes authority system, autonomous systems. The features that we are planning for Rocky, in the case of Neutron Core, we are implementing what we call multiple port bindings. And essentially what that allows customers to do is to better support live instance migration. Essentially, right now, when you migrate an instance, you start the migration, you move the instance, and then you create the binding for the port. And if that binding for the port fails, then your instance migration completely fails. What we are doing is that we are creating the binding for the port, for the ports of that instance in the destination host before you move the instance. So you know that your ports are bound to that destination, the binding succeeded, and then you move your instance. And what this also allows you to do is to be able to change the backend where your instance, the networking backend where your instance resides. So say you are running your instance with a compute host with an OVS backend. You move your bindings to a compute host with a Linux bridge backend, and then you move your instances. So you can change the backend of your networking backend. We are implementing port forwarding for floating IP. So in other words, you have one floating IP, and you have several TCP ports associated to that floating IP, and we can forward that now to ports in the deployment. As I already mentioned, we're improving the predictability of the API responses, and we recently delivered the change of configuration without services restart, right? In the case of Neutron Live is a project where we've been moving all the components in Neutron that need to be imported by the rest of the projects in the family. What we are trying to accomplish is that we don't want the other projects to need to import from Neutron. And the big thing that we are trying to accomplish during the Rocky cycle is that we're moving all the DB layer in Neutron to Neutron Live. As far as firewall as a service, we are implementing a pluggable backend driver. We are implementing remote firewall groups. They are going to be adopting the events logging API that is already implemented in security groups in Queens. And we are adding address groups. In the case of VPN as a service, we are going to support the newer version of LibreSWAN. We are implementing quality of service for VPN as a service. We recently merged the spec, and we already have a code on the review for that. And we are removing unmaintained drivers. In the case of the Midonet backend, essentially the focus there is that we are hardening the code. We are making it more resilient to failures, and that's the focus for the Rocky cycle. In the case of Open Daylight, full sync and recovery in the case of ODL failure. The team has been investing a lot of time implementing L3 flavor drivers, and essentially an L3 driver is an L3 flavor driver is a different ways to implement the L3 service, and they've been adopting the flavor approach. We're adding ODL, oxygen support, and the DHCP support in ODL instead of using the reference implementation DHCP agents. In the case of OVN, they are implementing port groups, and this is really a way to assign a UUID to a group of ports, and then you can, from the point of view of the API, manipulate them as a set. For example, assigning security groups to that group of ports. They are placing a lot of emphasis on migrating from the ML2 OVS reference implementation to ML2 OVN networking. And of course, enhancing the scalability of security groups and improving the documentation. As far as BGP VPN, they are implementing a support for router association attribute to better control the routing. And as far as pipe, improve support for load balancing. For those of the team members in those projects, did I miss anything that I should highlight? Anything that you guys want to add? Okay. So cross-project work that we are doing in this cycle, we are working with NOVA essentially in two efforts. I already mentioned the multiple port bindings for VM migration. This is really a cross-project initiative. We do our piece with multiple port bindings, but they need to take advantage of that on the NOVA side with the migration of VMs. And just last week, we merged the specs both on the NOVA side, on the Neutron side, for string minimum bandwidth support. What that means is that today you can assign a minimum bandwidth quality of service policy rule to a port, to an instance port. So we go to the data plane and we enforce that minimum bandwidth requirement in the data plane. But nothing prevents NOVA from scheduling instances in that compute host and oversubscribe the data plane. So we need to cooperate with NOVA to make sure that NOVA is aware that we have a minimum bandwidth requirement on those ports, so they don't oversubscribe the NICs. And that's work that we are doing with them using the placement API in NOVA, so we are influencing what we are doing is that we are influencing the host where NOVA is going to schedule the instances, and they are letting us know where they schedule that instance so we can reflect that in the binding of the process. And beyond Rocky, we have we also recently merged an exciting, I found it exciting, a spec, a neutron-to-neutron interconnection. That's something that we are looking to implement beyond Rocky. We have a proposal to extend the firewall as a service API to associate with more resources. In other words, not only with ports, but we also with networks and other kind of resources, and associate dynamically with VMs using VM names and labels. And we are preparing for the world where we are not going to have a Python 2.7 anymore, and we need to live exclusively in Python 3. How to give feedback on a continuous basis? Please attend our weekly meetings. We meet on Mondays at 2100, one Monday, and then the following week, we meet on Tuesdays at 1400 UTC. And that's pretty much to make it possible for people from different geographies to attend the meeting. File a bug in Launchpad. We have a process of continuously triaging the bugs, and we have a process that we call RFEs, request for enhancement. So if you file a bug, and that bug is not really a bug, it's really a request for Neutron to be enhanced in some way, we classify that according to that, and then we have a meeting every Friday at 1400 UTC, and that meeting is can be attended by anyone who's interested in promoting an enhancement, a new feature in Neutron, and we can discuss your proposals for new features in Neutron. We have a subset of the Neutron core team members. We call them the drivers, and they make the decisions as to what can be implemented based on the request from enhancement. We try to be as fast as possible making those decisions. So, and as I said, it's open to anyone. If you want to attend, you're more than welcome. And finally, send a message to the mailing list or ping us in the Neutron channel in Freenode. And how to contribute? Well, again, attend the meeting, and we have a guide for prospective new contributors. Please take a look, read the material, and help us improving both the project and the documentation. And with that, we are open to questions. Thank you so much. And I realize that I'm the last presentation between you and beer time, so or wine time.
I have a selfish question. Can you point me at the dynamic routing folks? Because I have a bug that I'd like to discuss with them.
So come and discuss it with me.
Okay.
Yeah.
Just while on topic of the dynamic routing, it's still the case that we cannot run more than one peering per agent?
I think it's still the case, yes. Yeah, and if that needs to change, I would suggest let's file an RFE and we can take it from there. Yeah. Yes, sir.
Could you expand on the logging of events for security groups, what that actually entails?
So security groups is, so the events logging is, you capture, so you define the rules that allow or not allow the traffic to a certain port. And what the logging API does is to allow you to specify, okay, I want to capture what happens with those rules, whether traffic was accepted or was not accepted, and that's logged in the database, and then you can exploit that.
Okay, that's exactly what we want. Thanks.
Yeah.
You mentioned in networking oriented project grouping of ports APIs that will be introduced.
The what?
Grouping of ports.
Yes.
It will be on API for ODN, or it will be API for Neutron core.
That's something that they implemented on their own. It can be discussed to be done in the Neutron core, of course, yeah. Well, with that, let's go have some fun. Thanks so much.